Welcome students to this session on transportation problems. In this session, we will discuss how we apply the least cost method to find out the initial basic feasible solution of a transportation problem. In the previous session, we have seen how by applying northwest corner rule, we find out the IBFS of a transportation problem. Northwest corner was one method of finding out the IBFS. The second method was a least cost method. So in this session we will discuss about how an IBFS is arrived at by applying the least cost method. So unlike your northwest corner method, where your first allocation was to the northwest corner cell of the transportation matrix, here in least cost method we are applying the logic that the first or the initial allocation will be allocated to that cell which is having the least cost in the transportation table. So your first allocation will be to that cell which will have the least cost for a minimization problem. We are considering again a minimization problem. So the first allocation will be to that cell which will have the least cost. So that one by one. So once you first allocate a particular quantity to the least cost cell, keeping in mind the rim condition, the supply and the demand constraints are not violated. So they have to be satisfied. So let us see what this least cost method is and how we apply the least cost method to get the initial basic feasible solution. Let us take the same problem which we took in the previous session and applied the northwest corner rule. We take the same problem here and apply the least cost method, a different method for the same problem. Same table, same time transportation matrix, 3 suppliers S1, S2, S3. S1 has a availability of 6, S2 has availability of 1 and S3 has a availability of 10 units. Similarly, customer D1 has availability of 7, has a requirement rather, again it's not availability, it's requirement. So suppliers have availability or capacities. Always these conditions, rim conditions, are capacities or the availabilities of the suppliers, and these rim conditions are the demands or the requirements. So a supplier's availability or supply, or the supplies, a supplier will have a particular capacity. Every factory or every plant will have a capacity or an availability. So S1's availability is 6, S2's availability is 1 and S3's availability is 10 units. Similarly, customer D1's requirement or demand is 7, D2's requirement or demand is 5 units, D3's requirement or demand is 3 units and D4's requirement or demand is 2 units. And these are all the cost elements. So S1 to D1, 1 unit of transportation will cost 2 rupees. S1 to D2, 1 unit of transportation will cost 3 rupees and so on. So how you read a transportation table, what are the different elements in the transportation table, we already understood in our previous session. So let us now proceed and apply the least cost method. Here in the least cost method, first consideration will be to identify that cell which has the least cost. When I look across the entire table here, I can find here cell S2D2 has a least cost of 0. So my first allocation will be to that particular cell S2D2, because S2D2 has the least cost cell. We are not taking into consider any direction here. Northwest corner, first in the northwest corner your first allocation was to S1D1 because it was at the northwest corner. Here you are not looking at any directions or any corner. You are only looking, the logic is to allocate first to that cell which has the least cost. So in this case the least cost is 0. So first allocation will be to S2D2. How much will you allocate to S2D2 now? Once you have identified as S2D2 as the cell which is having the least cost, you can see here D2 has a requirement of 5 and S2 has a capacity of 1. S2's capacity is 1 and D2's requirement is 5. You can see here supplier S2 has a availability of 1 and customer D2 has a requirement of 5. So the S2 can only supply 1 here, not more than 1, because S2's capacity is 1. So you allocate 1 unit to D2. S2 will transport 1 unit to D2. So this particular availability or the capacity of S2 is fully utilized here. Now out of this 5, 1 is already given, so 4 is remaining here, 4 units are remaining. So D2's overall requirement was 5. D2's overall requirement was 5. 1 unit out of it is catered to or supplied by S2. So another 4 units are remaining for D2 to be fully satisfied. So what is the next step now? Now again look into the table now, and now which is the out of the remaining cells, which is the cell with the least cost here? You can see here 2, S1D1 with a cost element of 2. This particular cell is the cell with the least cost. So your next allocation will be to this cell. Just check. Supplier S1's capacity is 6 and D1's requirement is 7. So supplier S1 can only give 6 because that is the capacity, that is what he can give. S1 can only give 6 units. So out of this 7, 6 units are already taken care by supplier 1. So another 1 unit of requirement will remain for D1. So this particular row now is fully satisfied because all the capacity is utilized now by S1 by distributing its quantity of 6 to D1. So now next step, which is the minimum now? Minimum cost cell now out of the remaining cells. So S3D1 with a cost element of 5. So only 1 is remaining. D1's 1 requirement is remaining. So you can only give 1 more here. The S3 will supply 1 unit of the remaining. So this particular 1, what was remaining, D1's requirement of 1 which was remaining, the balance 1, that is catered to by S3 because of the remaining cells. S3D1 as the least cost element here with a cost of 5. So 6 plus 1 7. So entire D1's requirement is taken care of. Now what is left now is S3D2, S3D3 and S3D4. So S3 out of these 3 cells, now S3D2 is now the least cost cell. S3D2 is the least cost cell. So your next supply will be to that particular cell S3D2. So here out of 10, now 9 are remaining because 1 unit is already taken and supplied to D1. So 9 units are remaining with supplier 3. So now out of this 9, D2's requirement is now 4 because that is what D2 now requires, the balance 4 out of 5. So that 4 will be catered to here. That 4 will come here. That 4 will come here. So this is fully satisfied now. D2's full requirement is satisfied. Now what is left now? 5 units are left here. 5 units are left. So out of S3D3 and S3D4, the 2 cells which are remaining, S3D4 with a cost element of 9 is the minimum cost cell. So next allocation will now go to S3D4. S3D4, this cell, S3D4 cell. How much? You can see here D4 has a requirement of 2 and S3 can supply 5, but D4's requirement is only 2. That 2 will come here. That 2 will So 2. So what is remaining now? Out of this 5, S3, 3 units are remaining. That 3 will go to this particular point, that is customer D3. Customer D3. So you can see here all the rows and columns are now fully satisfied. You can see here all the rows and columns are fully satisfied now. You can just S1's entire capacity of 6 is given to D1. S2 had a capacity of 1, that is catered to D2. Similarly, S3 had a total capacity of 10, out of which 1 unit is given to D1, 4 units to D2, 3 units to D3 and 2 units to D4. You can check this also. 6 plus 1 7, full requirement over 4 plus 1 5, 3 and 2. So this is the final allocation that you get by applying the least cost method. Now as you have seen by the northwest corner as well as the least cost method here, what solution you get is not optimal. So this is just the first phase of solving a transportation problem. So whatever solution you will get is just the initial basic feasible solution. Correct? Initial basic feasible solution. It is not yet proved that this is optimal. So you have to apply the modified distribution method, the optimality test on this IBFS, which will be discussed in the subsequent, whenever in a separate video we will discuss about the modified distribution method. Right now please understand this least cost method. You can see here the same solution here represented. S1 to D1 6 units, S2 to D2 1 unit, S3 to D1 1 unit, S3 to D2 4 units, S3 to D3 3 units and S4 to D4 2 units. And the total cost will be 2 into 6 plus 1 into 0 plus 5 into 1 plus 8 into 4 plus 15 into 3 plus 9 into 2. What is given here? It totals up to 112. It totals up to 112. And also you can see the total number of filled cells 1, 2, 3, 4, 5, 6. The total number of filled cells are 6 here. So since the total number of filled cells is equal to m plus n minus 1 condition, this IBFS solution by least cost method is non-degenerate, because the total number of filled cells here equals the m plus n minus 1 condition. M is the number of rows, which is 3, and n is the number of columns, which is 4. So in this problem the solution is non-degenerate, and you can also see the difference between the northwest corner rule and the least cost method. In the northwest corner rule, in the previous video you have seen that the same problem we applied northwest corner rule, we got a degenerate solution and a value of rupees 116. Same problem, same data, you have applied a least cost method. So you can see here the total cost here comes to rupees 112. There is a saving of 4 rupees here by applying least cost method over northwest corner method. Correct? And also the solution here is non-degenerate. So directly you can apply modified distribution method here. Modified distribution method to this particular IBFS obtained by the least cost method. So generally when we speak about this IBFS, so any one of these, unless it is specified, see if it is specified that you find out the IBFS only by least cost method, you apply least cost method. But usually all these IBFS solutions will give you an IBFS which may be different, but finally when you test for optimality applying modified distribution method, you will finally arrive at the optimal solution. Only thing is the number of iterations that you may have to do to get the optimal solution may differ depending upon the choice of the IBFS method that you have used. So this is the least cost method. Hope all of you have understood. We have seen now northwest corner rule. Now we have seen the least cost method, and in the next video we will discuss about the IBFS solution by Vogel's approximation method. Thank you.